he argues here is no matter what choice you take of section of a piece of n, it gives you the same formula. And that's what he argues starting at this fourth paragraph at the end of page 93. So going right into it.
Sure.
Proof. This chair. Alright, so suppose that z prime prime element of, well, I'll draw this diagram over here. So it's because I and P are chain maps, the following diagram commutes.
Turn the previous picture on its side. You know.
Yeah.
Right there.
So.
No. Am I wrong?
I think so.
What was I thinking? Oh no, I'm wrong. Never mind. I was thinking of this one.
This is
Yeah.
partial, and this is partial prime prime. So then he sort of circles this part of it. This is essentially the path we're going to be chasing.
Okay.
And he says, moreover, the rows are exact by exercise 5.8. So this is what we have to work with. So we got these are exact and everything commutes. So initially we're starting with an element of the n cycles of this group here. Because essentially what we're going to do to give show that this induces a well-defined map on the nth homology group, we need to show later that this sends all boundaries to 0, and so it's well-defined. But for now we're just going to be looking at elements of the cycles. So since this is a cycle, we have the boundary map applied to it as 0. So since P is surjective, there exists...
Isn't that... Sorry to be... Well... I guess you don't have to put a sub n on it if you don't want to. Never mind. It's fine.
Yeah, he doesn't put a sub n on it, so
that's not anything.
Oh. He's got it in the lemma, but not in the proof. Okay. Yeah, it's cool. Fine,
Yeah.
fine.
So, let's see, Zn. So essentially, when he says lift z prime prime to Sn here, essentially, I think what he's saying is, because it's surjective, there exists an Sn element Sn such that P of Sn is equal to Zn prime prime. So then he takes
So each...
the
That's the boundary.
partial of that, yeah. So essentially he's saying here that Zn prime prime is equal to, well, Sn is equal to P inverse of
Can I ask a dumb question? What is
Zn
Sn?
prime.
It's an element. Of
Sn is an element
Sn.
of Sn.
What's the relation of Sn and the boundaries in the cycles?
The
Which Sn?
this is surjective, so there exists an Sn in here such that P of Sn is equal to Zn prime prime, which is in here. It's a cycle in here.
Okay, so boundaries or cycles could be subsets of Sn. I'm just
Right,
okay.
Right. Yeah.
I'm sorry. I'm just had a moment of
So
lost.
we're sort of working towards
Okay.
That formula.
showing this formula is well defined.
Yeah. Okay. So Zn prime prime is just a particular subset of Sn.
Right, Zn prime prime is the cycles of Sn prime prime.
Right.
Yeah. So we're able to move here. Now we're moving down by taking this boundary map. So our next step, in order to so this is I, this is P. But these are different, and he doesn't distinguish them, but I'm going to put hats on them to make it easier.
Okay.
So I guess
Can I-
technically this should be hat here.
No.
Forgot
Can I
to
do
mention
something?
that.
Let me do something. So let's see here. Like here is your z prime prime, right?
Yeah.
Then you did partial prime prime, right? Or what's your next move? I mean, like where are you sending
It's
that?
the P.
Here. Sn.
So you're sending that, then you're feeding that to Pn inverse, right?
Yeah.
So you want this to be here. Right, and then,
Right.
Now
And that's
that-
equal to Sn.
right, exactly, that's, yeah, and that's in Sn. And then the
Well, it's
bound-
equal to little Sn. It's a notation.
Oh,
we're
you're,
using.
okay, I'm sorry, you were saying that's equal to little Sn, but that's, no, that would be, that's not unique.
Right.
No.
But
We need to show the
It
uniqueness
is
later.
fine.
But you need to show them that whatever that is, when you whatever departure from uniqueness there is, perhaps when you hit it with the
Right.
is that
With the
ambiguity washed away by
Right.
the end bound by this map, by the derivative, or maybe
I
mean,
remember-
it doesn't have to get washed away there. It could get washed away
Yeah.
here,
Yeah.
but it has to be removed at some point.
Right.
And so then that goes to here under that.
Yeah. So this is boundary Sn, and we need to show that this is in the image of I bar. So then when we take the inverse of that, we get a map to here.
So that gets you an element over there, right?
Right.
Okay.
So they say. See, I lost my place here.
I'm sorry.
That's okay.
Just
So they argue by commutativity. He says partial Sn is an element of the kernel of I bar. No, I'm sorry, not P bar. Yeah. Which is equal to the image of I bar. So why is that? If we look at, think for a second here. If we look at, oh yeah, partial prime prime of P of Zn prime prime. So that's going this way. By the fact that it's a cycle,
Or we want P of S.
this has to be,
P of
right.
F, which is
Yeah.
Yeah. Right. So P bar.
so we're going this way, and P of Sn gives us Zn prime prime. And then taking the partial of that is 0. by commutativity of the diagram, this is equal to
P bar.
partial of p bar.
Other
P
way.
bar partial.
Oh, makes sense. So this is equal to 0, and
On
of Sn.
Yeah.
Yeah. So then,
So it's in the kernel of P bar. So it's in the image of I bar.
right, I guess this is in the kernel, yeah. So that gets us here. So that shows us that I inverse of partial Sn is well defined. So our next step here is to show that in this step here where we had to use surjectivity of P,
Right.
that's well defined. So essentially what we do
You were
here,
to consider two different lifts.
we consider a different element of Sn.
Yeah.
So suppose we had instead,
They would differ by what? Like a.
Not in the boundary, I think it's.
well,
Oh, something in the boundary? Wait, it's fine. Then you go on.
it's going to be in the kernel of P.
Okay, that's what I was thinking.
Is how it's going to work. So suppose instead we had,
Because they both have to map to, like they both have to map to z prime prime. So like the difference of
right,
whatever you want. Are we gonna give this a name like Sn?
sigma sub n.
You're gonna call it sigma sub n instead of Sn.
That's
Yeah.
what he calls it in the book.
Okay, so like Sn minus sigma n should map to something. They should map to Zn. Z prime prime minus Z prime prime, which should be 0, right? I mean, like,
Right, so we have this, and he claims that Sn minus sigma n
mhm.
is an element of the kernel of
P.
I guess in my notation. Well, no, it's a regular P. Yeah.
Yeah.
I'm just making sure I'm getting the notation right. So, why? Because P of, so since P of sigma n is equal to P of Sn is equal to Zn prime prime, implies that
Right.
P of sigma n minus P of Sn is equal to 0, which, because P is a homomorphism, implies P of sigma n minus Sn equals 0.
Right.
That tells us that sigma n minus Sn is in the kernel of P, which, by the way, is in the image of, let's see, Sn prime.
I?
Is it I? Yeah. So then that shows us that it's well defined. So all that.
Why is, I'm sorry, just so if you chose a different. Oh, well. How is that? Sorry.
Since if you chose a different one, the difference of them is in the kernel of P.
It's short
So-
exact. That's the image of I.
How does that help us, though? Let me backtrack a second here.
Is it based on the commutativity of the p derivative prime prime with derivative p bar? I mean, if the extra thing is sent to 0, I mean, because we're saying that sigma is basically Sn plus something that goes to 0 under p, right?
Right.
So
The issue is in our map, we're not actually using p, we're using p inverse.
yeah, but the
But I guess by commutativity, you're saying...
I'm saying that's right. I have to write. I'm not sure. I'm saying like here, if it's not this, it's this plus some epsilon. You know, where this epsilon is sent to 0 under p, but we know that partial prime prime p, right? P inverse z prime prime plus this epsilon piece is equal to the other way, p bar partial p inverse z prime prime plus epsilon, right? And the thing is, this you've argued goes to 0. It's in the kernel of p.
Right, but where are you getting this from?
Oh, I'm just
That's equal to...
I'm just using this commutativity of this here. So like this is p like this versus
Yeah.
like that. I'm not sure that helps us or not, but that tells me what I'm experimenting.
Yeah, I don't know if that helps us because we're going here.
What was that? But it tells us something about this map, see?
Well, it tells us something about that map when we also apply partial to it.
But don't you do that?
Or not partial, but this p hat. Because we don't actually apply p hat in our formula.
Never mind. I thought I might have. It's something probably not that complicated.
Yeah, there's probably something. It probably does have to do with commutativity. I thought I understood that, but I guess not. That's at least
I mean, we
decent
want
progress towards understanding.
We want the formula, right?
To be independent of our choice of Sn.
Right. So it would suffice to show that, you know, partial n. Why is. I just need. Excuse me. So we've denoted this p inverse z prime prime thing by Sn, right? What we need to show is that if you feed I n minus 1 inverse partial n something from the kernel of the p map, right? That just gives you a boundary. Just to write it down again.
What he's saying is that
We want to show that we want to show that I n minus 1 inverse partial n, what I've called epsilon, which would be your Sn minus sigma n. This anyway is in the kernel. We know that that's in the kernel of the p map. We want to show that this is a boundary. If you can show that that's a boundary, then you've done it.
well, he says I don't know why he used primes there, but then he says Sn minus 1 prime minus sigma n minus 1 prime is equal to partial prime xn prime, which is a boundary.
So he's
here.
called. So he's called.
So he's somehow able
He
to
is
bring it
his-
down here.
I think he's using commutative.
It's got to be. Yeah, like you said.
But what even is Sn minus 1 prime?
Those are the ones that map to boundary of Sn minus sigma n minus Sn. So Sn minus 1 prime is says I Sn minus 1 prime is equal to boundary of Sn at the bottom of page 93, and it's the same with sigma n minus 1. And since
Oh.
I is a homework.
Okay, so they're
Whoa.
using the injectivity of I.
Or is it just that? Well,
So like the xn prime that they define is what maps to Sn minus sigma n by I, since Sn minus sigma n is in the image of I. Sorry. Just kinda-
this is the partial n, right?
Yeah.
So we have this xn and xn prime, which is an Sn prime, which
Where is this in the picture?
That's what.
that's I bar, or
Yeah.
I bar inverse.
Because in the book he just calls both of these I.
Oh, you're.
So I called that I bar to avoid ambiguity.
Okay.
So that'd be I bar inverse.
Oh, okay. I mean, you just want to bring the partial over there, right?
Yeah.
Because then it would show it's a boundary.
But you can do that though, because these commute, right?
I mean, it's definitely true that. It's, I think what you're saying, so like partial n I, right, is equal to what? Partial prime? No, it's equal to
I bar partial prime.
I bar partial prime.
Yeah.
So if we do I bar inverse on both sides, we get but the thing is I is epsilon in the image of I?
Yeah.
It's a right? That I
Yeah.
is that I is rejection?
It's an injection.
Oh, but we know that epsilon's in the image of I from what Nate wrote on that board.
Right, you just apply the same argument to sigma n.
Since
So-
it's in the kernel of P, it's in the image of I.
Oh, then that means that this epsilon can be rewritten as like I times something else.
I have xn. He write xn prime.
Xn prime is what he calls
Yeah.
it. And then you've got I inverse this, that. So we can go and rewrite it as partial n partial prime xn prime.
Okay. Then
Oh
that
my.
shows it's a boundary.
Yeah. Yeah. Well, that was. Oh no, that was fun. I don't want to give them false hope.
So then the last step.
Oh, okay.
So that gives us a well-defined map from Zn prime prime to, Hn minus 1 prime, right? So we turn this into a map from Hn prime prime to Hn minus 1 prime. We need to show that the boundaries, so Bn prime prime is contained in the kernel of the map, which I don't think we gave a name to.
I'm gonna let you guys finish it up. You can. I must run, unfortunately. I'll I'll watch the video. Don't worry.
Okay.
Yeah, it's kind of like
The map.
that.
But there we can just use commutivity again. Remember what the argument was. Well, I guess if you have a boundary here, it's going to be in the image of P, right?
Mhm.
So if we have Bn prime prime, Bn prime prime is equal to P of S for some S in Sn.
Mhm.
So in our map, so if we look at I sub n minus 1 inverse of partial n of Pn inverse of that P of S, those cancel out and you get boundary of boundary, which is 0.
Okay.
So then that shows that it's well defined. And there you go, yay. That gives us homomorphism. So mapping the class of Zn to the class of y inverse of
That's right.
Partial n
It's called
of-
DN. Forgot that.
Pn inverse. What did you say?
The mapping's called DN.
Oh.
Forgot about that. I don't know.
Oh yeah, thanks.
Because he loves
Forgot about
using those. Yeah, I know. He loves using those arrows so much.
Yeah, he does.
You forget what mapping is.
Of Zn. So, in other words,
DN is homomorphism.
Dn. There you go. That's all. Thank you.